So the bell rang right here, and we quickly did this. But if you look up here, we factored out the dy over dx. I have the 12y, but I'm missing that x squared plus y squared. So there should be an x squared plus y squared there. So this isn't no big deal. This isn't no big deal here. But this should actually be an x squared plus y squared here as well. So that's going to change our denominator. We get the negative 260 on top still. But now this is 10. So 120, and then minus, so now it's negative 180. All right, so the zeros go away, the negative goes away. I have 26 over 18. I can divide by 2, and I get 13 over 9. So the slope is 13/9. So you did it right? No, you can't do it a different way. It's wrong then.
No goldfish for you.
You foiled out. Yeah, so that is a way to do it, but it's not the preferred method. Because we prefer to get, correctly. Yeah, I know. But you will get the right answer in the end, okay? Technically, if we're plugging in an ordered pair here, and that's all we care about, if it doesn't specifically say determine the derivative, put it in dy over dx terms, then I guess once you take the derivative and you just substitute numbers in, you can simplify it down and get the same result. It's much better, though. It's much more powerful to do this correctly. Okay? All right. Next problem. Find dy over dx for this equation. Sine y equals x. Instead of y equals sine x, we have x equals sine y, basically. Yeah, but look at the graph. Isn't that cool? All right. Now we can take the derivative of both sides. So again, I'm doing d over dx to both sides. The derivative of sine y with respect to x will be what? Are we multiplying sine times y?
No.
We are not multiplying sine times y. It's the sine of y. So, yes, the derivative of sine u is cosine u times u prime, right? Well, u prime here would just be 1. So this on the left becomes cosine y dy over dx. And that dy over dx is outside. Equals 1. Now solve for dy over dx. And we get 1 over cosine y, which is? Is it secant? Okay. There you go. It doesn't say to plug in a point or anything like that, but that's your answer. So let me talk about the notation here first. It says find the second derivative, which you are going to do eventually, but I want you to find the first derivative. The notation here designates second derivative. If we take the first derivative, we wind up with dy over dx. But if we take the second derivative, the way we designate that is d squared y over dx squared. It doesn't mean that we're squaring anything. It's just notation denoting the second derivative. Okay? So go ahead and take the first derivative, and then we will work together to get the second. So the first derivative is basically like what we've been doing, right? Take the derivative of both sides with respect to x, and we get what? 2x plus 2y dy over dx equals 0. Good. Now we want to solve for dy over dx. So that means this guy has to move over here. And I have 2y dy over dx equals negative 2x. Now I can divide both sides by the 2y. And I get dy over dx equals negative 2x over 2y, which reduces down to just negative x over y. Yeah? Okay. So that's the first derivative, and I'm going to put a box around it because it's important. For the second derivative, we're taking the derivative of the first derivative. So we're going to start here. How do I take the derivative of that? Quotient rule. So dy over dx will turn into d squared y over dx squared, because I'm taking the derivative with respect to x of the derivative of y with respect to x. Maybe that's why there's squares involved, I don't know. Okay, so we need the quotient rule. I can put the negative out front, I can put it on the numerator, I can do whatever I want. What do I want to do here? Numerator, sounds good. So, what do I have? The derivative of f is negative 1 times the original g, which is y, minus the derivative of g is 1 dy over dx times the original f, which is negative x, over y squared. Okay, so let me simplify that down a little bit. D squared y over dx squared equals negative y plus x dy over dx all over y squared. Now what? Split them up. No. See, that's the problem. Because we're not done until we have all the dOI over dx's on one side, right? And right now, this isn't even the same thing. This is d squared y over dx squared, and this is just dy over dx. But I can't leave that sitting there. And you're trying to tell me something, now I'm going to let you. What were you trying to tell me? Oh. Somebody was trying to tell me something. Oh, it's just exasperation. How can I get rid of that? I want it to go away. I don't want it at all. No. There are tricks. There is a trick, and you are telling me tricks, but you haven't told me the right one yet. No. If I want something to go away, I can try to fancy one it out of there, but that's not going to work. I can try to cancel it out of there, but that's not going to work. If I multiply everything by 0, that's not going to work. Perfect. What do we do? Wouldn't it be nice if I could just turn it into something different?
Wait, do we use an identity of some kind?
I guess you could say it's an identity, yeah.
Identity.
No. It's still not gone.
Can't leave it.
No.
You're not going to find it there. You're going to find it on this board somewhere.
What? Oh, wait, equals negative x over y?
It's sitting right here. dy over dx is this.
Can I have a little bit for that?
No. So we substitute in negative x over y for the dy over dx right here. D squared y over dx squared equals negative y plus x times the negative x over y squared. You guys are going to encounter this a lot when you take second derivatives using implicit differentiation. What, did I screw something up? Dx squared, yeah. All right. Now we can simplify this down more. We have d squared y over dx squared equals the negative y plus, nope, Now it's minus. That becomes x squared over y all over y squared. Hopefully you can see that we have more simplifying to do here. What needs to be done? What needs to be done? I don't. Common denominator for the numerator. What will the common denominator be? So I need a y here, which means I need another y here. Yeah? Okay. Nice. D squared y, dx squared equals what?
Negative y squared x squared all over y cubed.
So I'm going to be a little bit more complete than that. I made that numerator one term, and I'm still dividing by that denominator of y squared, which is y squared over 1. Then we can leave it, change it, flip it up there, right? Okay. So now I have d squared y over dx squared equals something over y cubed. Negative y squared minus x squared. Can I factor a negative 1 out of that and make it a little simpler? So I'll put that negative out front like I wanted to in the first place on this problem. And then I'll write, so the negative is out front. So x squared plus y squared. It's looking pretty good, but we're not done. This can be simplified further. No. No. It'd be nice if we knew what x squared plus y squared was so we could simplify that down a little bit. Yeah, it's 25. X squared plus y squared is 25. So I can substitute that in, and I have d squared y over dx squared equals negative 25 over y to the third. And that is your answer. So on this problem, what do you need to see first? No. What are you supposed to see first? No. You need to find the tangent line to the graph. Okay? So don't just fall into a routine of just taking derivatives, okay? Make sure you understand what it is that the problem is asking you to do. So the ending answer will be what? An equation for a line. Okay? So in order to find the equation for the line that's tangent to my graph at a particular ordered pair, which they gave me, I need to do what? Take the derivative. We will have to differentiate implicitly because of all these y's that are in here, which means we'll have to solve for dy over dx, right? Now we've taken the derivative, what do we do next? Plug in your ordered pair that they're giving you so that you can find what? The slope of your tangent line. Then once you have your slope and you have a point, plug it into point slope form, simplify it down. Okay? So that's what we're doing on this problem. Now that we have some sort of goal in mind, we can go ahead and start the problem. So make sure you understand what the problem is actually asking you. Now I give you this cool looking graph here. This is the graph of this non-function. Root 2 over 2 comma root 2 over 2, probably somewhere in this region right here. So we're going to wind up with a positive slope. Probably your negative answer is wrong, yeah. All right, so let's just slowly take the derivative here, make sure we do everything correctly. Now, because we are about to take the derivative, I will ask you, what do we need to do to take the derivative? We need to do the product rule, yeah. So tempting, maybe, to distribute the x squared in, but all you're doing then is making another product rule from what was 1 to now 2 product rule situation. So don't do that. All right, this is going to be my f, and this is going to be my g, right? All right. He's my friend. Now what? So I get 2x. So, good. All right. And I have the original f eventually also. And because of the nature of g over here, my g is bigger than normal, more terms than normal. So I'm going to write that first. The x squared comes first, and then the derivative of g.
So we're going to have 2x plus 2y dy over dx.
Good.
And then equals 2y dy over dx.
Good. See, calculus is easy.
Yeah, here's where the algebra is.
All right, so now we need to do algebra. We got to get the dy over dx all by itself on one side. What should we do?
I see my mistake. I forgot about that.
I got a dy over dx buried here. I got a dy over dx by itself here. So I'm going to move all my dy over dx's to the left side. But in order for me to do that, we're going to do that weird distribution that we did before, right? The nice thing is, though, it's only one term here that I'm distributing in, but I am going to distribute. I'm also going to distribute here.
I was right except for I got the x squared, so I remember.
The reason I'm distributing here is because I'm going to wind up with an x cubed here and an x cubed here, and I'll be able to combine like terms then, okay? So here we go. 2x cubed plus 2xy squared plus 2x cubed plus 2yx squared, or x squared y. Let me back that off just so I'm writing things in alphabetical order. 2x squared y dy over dx equals 2y dy over dx. Yeah? Okay. So combine like terms when we have 4x to the third. These are not like terms. So plus 2xy squared plus 2x squared y dy over dx equals 2y dy over dx.
Okay, wait. I have a question.
So from here, we need to collect all of our dy over dx's on one side, move everything else to the other side, right? What should I do? So should I move this guy over here, or should I move this guy over here and then move these two terms over there? Move one term. So this is now over here. And then I factor out the dy over dx. So now on the right, I have the 2y minus 2x squared y times dy over dx equals, over here, the 4x cubed plus 2xy squared, and this term's out of there. Divide both sides now by the 2y minus 2x squared y, and you get your derivative. I'm also going to use the reflexive or the symmetric property to move the dy over dx to the other side. This is my numerator. This is my denominator. All right, now we have this thing in the right format, so let's see if we can simplify it down to make life easier. We can do what? Yeah, if I pull a 2 out of the top and I pull a 2 out of the bottom, the 2's form a fancy 1. Is that the only GCF that I can pull out of there? I can pull out an x in the top and a y in the bottom. Does that do me any good? Let's do it anyway. So I pull the 2 out, right, of the top, and I pull the 2 out of the bottom, and those are going to divide out. But the x in the top will not. The y in the bottom will not. So I wind up with 2x squared plus y squared. And I wind up in the bottom, the 2's are gone. I pulled that y out of there, so it's 1 minus x squared. So now we plug in the root 2 over 2 for every variable that we have. If I plug in root 2 over 2 here and I plug in root 2 over 2 here, that's a fancy 1. So they actually will disappear, even though they're different variables, because these numbers are exactly the same. So I'm going to eliminate those now and not bother writing them. So in parentheses, then I have 2 times root 2 over 2 squared plus root 2 over 2 squared divided by 1 minus root 2 over 2 squared. Yeah, so root 2 squared is 2, 2 squared is 4, so that becomes 1/2. I have 2 times 1/2, which is, so I get 1. Here I get 1/2, so 1 plus 1/2 over 1 minus 1/2, which becomes 1/2. Okay, this can probably be simplified as well. 1 plus 1/2 is 3/2 divided by 1/2. Leave it, change it, flip it. So times 2 over 1 becomes 3. So the slope at root 2 over 2 comma root 2 over 2 is 3.
I would just have it negative positive.
Probably you made more mistakes than that. We're not done. We're not done. Because we got to find the tangent line, right? So yeah, we just really simply make it sound so easy, because it is. Point slope form. I'll change colors. Y minus root 2 over 2 equals 3 times x minus root 2 over 2, and we're not done. Because I want to put this in slope-intercept form. It's super easy to put it in slope-intercept form. So we're going to distribute first, and we have y minus root 2 over 2 equals 3x minus 3 root 2 over 2. And now we add root 2 over 2 to both sides. So if I do that, I have negative 3 root 2 over 2, and I'm adding root 2 over 2 to it, so what do I wind up with? Negative 2 root 2 over 2, which simplifies down to just the square root of 2, but it's negative. So I have y equals 3x minus the square root of 2. That's my answer. Yes, the directions don't say put it in slope-intercept form, but the answer from here to here becomes much simpler when you do. And that's why we did. It'll have slope-intercept form in the back of the book.